Alright, so today we're going to continue with factoring. Remember from yesterday, we always looked for a GCF to divide all the terms by. I don't think that you'll actually have any that have a greatest common factor, but we should be looking for that. I think later on in this chapter we'll have sort of a mix and match of types of factoring problems where you'll have to do like every type of factoring that we've done so far. So we're going to look for a GCF, and then after you do that, you're going to evaluate, do I have a trinomial or a binomial? Remember, trinomial means that there's 3 terms. Binomial means that there's 2 terms. All right, and then we'll come back to this to refer back to how do you factor from there. All right, so problems 1, 2, 3, and 4, notice that these are all trinomials. 1, 2, 3, 1, 2, 3 terms. These all have 3 terms. Okay, so we won't do the binomial method yet, so we'll only be focusing on the trinomial method for now. All right, so we're going to look for a GCF, but 2, 5, and negative 3 can't all be divided by something. So now we're going to look at trinomial factoring. All right, if A is 1, then we're going to do what we did yesterday. But in this case, A is equal to 2. Right, that's A, that's B, and that's C. So we need to use the guess and check method. We know that the trinomial is going to factor into 2 binomials. There's not too many things that multiply to 2x. There's either 2x and 1x, or negative 2x and negative 1x. But typically, they're not going to have negative signs in front of both. So you can just assume that these will both be positive. All right, now I need to multiply to negative 3. Well, I'm going to use a pencil for this, because we're going to do guessing and checking, and if it doesn't work out, then we're going to erase and try something else. So what multiplies to negative 3? Well, I could multiply negative 3 and positive 1, or positive 3 and negative 1. So the guess and check method just means guess and see if it works. So we're just going to try this first one, negative 3, positive 1. All right, we're going to see if this works by doing first times first. That's 2x squared. Outer is 2x, inner is negative 3x, and last is negative 3. All right, now we're going to combine our like terms. Well, if I add these 2 together, then that doesn't give me my original. So I know that this can't possibly be right. All right, so I'm going to erase this. Try something else. Okay, so what if we tried positive 3 and negative 1? Okay, so if you, right, we said that didn't work. So we've got 2x squared minus 2x plus 3x minus 3. If I add together my like terms, I get 2x squared plus x minus 3. Well, that doesn't work either. Okay, so since those didn't work, that means I need to try to flip-flop my numbers. So you can try a positive 1 here and put the negative 3 there. All right, so we've got 2x squared. Outer is negative 6x, inner is plus x, and last times last is negative 3. If I add my like terms together, I get negative 5x. Well, that's exactly what I want, so that's a good sign. That tells me that I did it right. All right, so the guessing part, you just try different number combinations, and you do the checking until you find something that works. All right, so I'm going to show you a couple of shortcuts so you don't have to guess and check and go through this whole process every single time. But that's essentially what you're going to do. Some of it you're going to try to do as much in your head as possible, and that'll save you some writing. All right, so we know that in this problem, 3, 10, and negative 8, there's no GCF. There's nothing that they can divide into. So I know that if we look at my A term, I know that it has to be 3x and 1x. Right? It could be negative 3 and negative 1, but we said don't think of negatives in front. All right, so now I've got different numbers that I can multiply to negative 8. We have negative 4, positive 2, positive 4, negative 2, negative 8 and 1, or 8 and negative 1. All right, so we're just going to try a combination. So we've got negative 4, positive 2. My suggestion is we already know that these are going to multiply to 3x squared. We know that the last terms are going to multiply to negative 8. So really you just have to check the outer and the inner, and then see if it adds to the middle. So we've got 6x and negative 4x. If I add those together, I get 2, not 10. So since I don't even have the right number, I know that either I have to switch it or try a different one. So switching to like the positives and negatives, all that's going to do is flip-flop these. So instead of adding up to 2, it's going to make it add to negative 2. So that doesn't help. So if my signs are wrong, I switch the signs. In this case, my number is adding into 2 instead of 10, so I know the number is totally wrong. So that means I need to switch the actual numbers. So I'm going to put 2 here and 4 here. Okay, so now we're going to try, I guess we'll try negative 2 and positive 4 first. All right, so if I do outer times outer, I get 12. If I do inner times inner, I get negative 2. And actually, if I add these together, I get 10. So there's my correct answer. I know that it's going to be 3x minus 2 and 1x plus 4. All right, so we're going to keep going. So we got A, B, and C. The only thing that multiplies to 5x squared is 5x and x. There's not too many things that multiply to 2. We've got 2 and 1 or negative 2, negative 1. So let's just try 2 and 1. These are both positive. So check outer times outer, inner times inner. Oops. So we have 2x and 5x, and that already adds to 7x. So that's exactly what we wanted, and therefore our problem is done. Okay, last one like this. Multiply to 6x squared. So this time, we actually have a couple of options in the front. Okay, so either 3 and 2 or 6 and 1. And for the last numbers, we've got 3 and 1 or negative 3 and negative 1. Well, let's look at our middle term. This is negative. So I probably am going to need negative signs somewhere. Otherwise, how am I going to add up to a negative middle number? So I know that we don't even need to try 3 and 1. So let's try negative 3, negative 1. All right, so if I add, multiply my outer, I get negative 3x, inner negative 6x. If I add, that gives me negative 9. That's not negative 11. All right, so that number is wrong, so switch the numbers. So try the 1 here and the 3 here. All right, so if I multiply, I get negative 9x and negative 2x. And when I add that, I get negative 11x. So that's the correct one. Since I found the correct answer, I don't even need to bother with this other set of binomials. All right, so when you're ready, flip to the back. All right, so these have the same thing. We've got trinomials. All right, what multiplies to 3x squared is 3x and x, and we're going to try what multiplies to negative 5. All right, so we are going to try, let's just do negative 5 plus 1. So outer times outer is 3x, inner times inner is negative 5x. If I add these, it gives me negative 2. So it's close. I have the right number but the wrong signs. So since my signs are wrong, all I need to do is switch my signs. Make that positive and make that negative. All right, so let's double check now. This should give me negative 3x, and this should give me positive 5x, and when I add them, I get positive 2x. So I know it should be 3x plus 5 and x minus 1. All right, so what multiplies to 5x squared is only 5x and x. Positive 3, we got 3 and 1, or negative 3 and negative 1. Well, since that middle term is negative, I think that I can cross off my positive numbers. I know I have to try some negative numbers. So let's just try negative 3 and negative 1. Outer times outer is negative 5x, and inner times inner is negative 3x. If I add those together, that gives me negative 8. So I'm good. All right, remember, if the signs are wrong, change the signs. If the numbers are wrong, change the numbers. That's when you're checking. Okay. All right, last type of problem for today. Remember, we're always looking for a GCF, but there's no coefficients in front of these, so we don't have to worry about a GCF for today. But this is the other type of problem, which is a binomial. So what happens when you have a binomial? This is called the difference of two perfect squares. Difference means that you are subtracting, right? All these problems are subtracting. And a perfect square is something that you can take the square root of and you get a whole number. So if we look at what's being squared here, this is a times a, right? This is a squared. What's being squared here, what's the square root of 16, is 4. So this is like a squared minus 4 squared. So this is a really quick factoring if you look at the shortcut. So we just want to know what's being squared to give you the front. So a times a, that'll give me a squared. What's being squared to give me 16 is 4, so I know it's 4 and 4. One of them has to be plus, and one of them has to be minus. And that's it. That's your final answer. The reason why this works, if you check it, if I multiply first times first, and outer times outer, inner times inner, and last times last, what happens to those? They cancel out, right? Leaving you with just an a squared and a minus 16. You don't have to do this. You can just go right to the answer. But I just wanted to prove that that really works. All right, so what's being squared here? Well, d times d gives me d squared. 7 times 7 gives me 49, so that must be 7 squared. So this tells me that it should be d minus 7 and d plus 7. All right, and number 9, if you don't know what's the square root of 121, you can use your calculator. So the square root of 121 is 11. Okay, so that is e squared minus 11 squared. Just remember that one term has to be plus and one has to be minus. So it's e plus 11 and e minus 11. And then on this one, f squared, what's the square root of 1? Now make sure you're looking at the square root of 1, not the square root of negative 1. Right? Square root of 1 is just 1. Right? So this is f squared minus 1 squared, meaning this should be f plus 1 and f minus 1. Now notice that it doesn't matter where your plus or minus is as long as you have one positive and one minus, so you can switch them around when you have those written down. Alright, and then that's it for factoring. Tomorrow we're going to be kind of combining a little bit of day 3 and day 4 into different types of factoring that you have to use all the concepts all at once.